So the first one, which you'll find on my website, which is Fractions Edition 00, asks students to really make partners to a whole or to add fractions together that end up with sums less than 1. And at this point, we're working with fractions with the same denominator or a common denominator. So students here, really important, need to make the connection that in 1, there are 4 quarters. And when my denominators are the same, so here we have 4 and 4, then the numerators, 3 and 4, really behave very much like whole numbers. So if students apply their knowledge that 1 plus 3 is 4, then 1 quarter plus 3 quarters will give me 4 quarters. Next, we'll move on to Fractions Addition 01. Now, in this case, the question itself looks a lot more complicated at first glance. We are working with numbers or fractions greater than 1, and we are also working with a combination of mixed numbers and improper fractions. But the sum in this deck of cards is always a whole number represented as a fraction. So we're really encouraging students, or I'm really encouraging students, to look at the relationship between 24 and 6 and think about it as a division. So 24/6 is really 24 divided by 6, which is 4. So this addition question really looks like this. What number plus 2 and 5/6 is equal to 4? The number line is an effective visual representation of the addition we're looking to do. So 2 and 5/6, and I want to add or find out the missing add-in to get to 4. So we'll pick a friendly benchmark of 3. 2 and 5/6 plus 1/6 gives me 3. And then the difference between 3 and 4 is 1. So 3 plus 1 is 4. So if I combine these two parts together, I get my answer of 1 and 1/6. So in this deck of cards, Fractions Addition 02, this is our last step before students start working with different denominators, and they're really being asked to look at improper fractions that aren't whole numbers, as well as mixed numbers, and kind of make sense of the equation, whether it's a missing add-in like this or just a straight question where they have to find the sum of two fractions. So in this case, there's actually 2 ways that students have been exploring these kinds of questions. Option number 1 is to convert both numbers to improper fractions. So in this case, 5/3 plus what is equal to 7/3. So if we look at 2 and 1/3, 2, if I ask students how many thirds in 2 wholes, it is 6. And then we also have the 1/3, so 1/3 plus 6/3 is 7/3. And in this case, again, because the fractions have the same denominator or common denominators, then the numerators behave very much like whole numbers. So 5 plus 2 is 7, which means that 5/3 plus 2/3 will give me 7/3. The other option is to convert both numbers to mixed numbers. So in this case, students will look at 5/3, or represent that as a division question, 5 divided by 3. 3 divided by 3 is 1. And the difference now between 3 and 5 is 2. And 2 divided by 3 is 2/3, which gives me an equation of 1 and 2/3 plus what number gives me 2 and 1/3. So most students that choose this route of going with mixed numbers are fairly flexible mentally of finding the missing addend. But in the case where a number line could help, we have 1 and 2/3, and we're looking to find the difference between that and 2 and 1/3. So I'll benchmark 2 because it's a nice number in the middle. 1 and 2/3 plus 1/3 gives me 2, and 2 plus 1/3 gives me 2 and 1/3. And if I find the sum of those two fractions, I will get, again, an answer of 2/3. So it's really important to recognize here that the answer in both cases is the same, 2/3, because really it's just the same equation. And that students are encouraged to not only use whichever method they're most comfortable with, but ideally they would be able to use either methods depending on what the numbers are or the equation or the situation. Thanks for watching this video. You'll find some practice cards on my website.